Welcome to question 1 of the 2009 Mathematical Methods Exam 1. In this video we will be looking at the solutions and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For part A we want to differentiate x log e of x with respect to x. So the first thing we can recognise is that this is two functions multiplied together, therefore we can use the product rule for differentiation. So to help apply that rule, we're going to let u be the first function, which is x, and v be the second function that's multiplied, which is log e of x. Next up, we're going to calculate du dx, which is simply going to equal 1, and dv dx, which is going to equal 1 on x. So from the formula sheet, we know that the derivative d dx of a function u times v is equal to u times dv dx plus v times du dx. Therefore, for this question, the derivative d dx of the function x log e of x is equal to the function u, which is x, times the function dv dx, plus the function v, which is log e of x, times du dx, which is simply 1. So if we simplify this, x times 1 over x is simply equal to 1, and then log e of x times 1 is simply log e of x. So that is the answer for part A of this question. So from the examiner's report you can see that 3/4 of students got this answer fully correct, and that it was a quite straightforward differentiation question which involved the use of the product rule. One thing that was done poorly is many students simplified x times 1 over x as 0 rather than 1. So just be careful when you're simplifying fractions. And when that occurred, all that was left was the logarithm term, which wasn't the correct answer to this problem. For part B, we have the function f of x equals cos of x divided by 2x plus 2, and we're asked to find the derivative when x is equal to pi. So the first thing we can recognise is this is a function divided by another function, which means we can use the quotient rule for differentiation. So to help apply the quotient rule, we're going to let the function u be the function that is in the numerator, which is cos of x, and we're going to let v be the function in the denominator, which is 2x plus 2. Next we calculate the derivative du dx, which is equal to negative sine of x, and you can look that up on the formula sheet, and dv dx, which is simply going to equal 2. Next, from the formula sheet you can see that the derivative d dx of a function u divided by v is equal to v times du dx minus u times dv dx, all divided by v squared. Therefore, for this question we'd have f dashed of x is equal to the function v, which is 2x plus 2, times du dx, which is negative sine of x, minus the function u, which is cos of x, times dv dx, which is 2. And all of that will be divided by v squared, where the function v was 2x plus 2. Next we need to find the derivative when x is equal to pi, so therefore we have f dashed of pi is equal to 2 pi plus 2 times negative sine of pi minus 2 cos of pi. And then that is still going to be divided by 2 pi plus 2 all squared. Now, using our knowledge of exact values, sine of pi is simply equal to 0, and cos of pi is equal to negative 1. Therefore, the derivative evaluated at pi is equal to 2 pi plus 2 times 0 is simply 0, and then we have minus 2 times negative 1, so it's going to be positive 2 on the top line, and then on the bottom line we're going to have 2 pi plus 2 all squared. So that is the answer for part B of this question. So as you can see, there was only about a third of students getting full marks for this question, and the examiner goes on to say that the quotient rule was appropriately attempted by most students. However, too many students did not include brackets, so that means that the expression wasn't correct, and they often incorrectly cancelled out the 2x plus 2 in the denominator, so this one here, with a 2x plus 2 in the numerator. But because that isn't a common factor in the numerator, it's not appropriate to cancel it. And furthermore, a majority of students did not substitute x equals pi correctly into their derivative.